Hello students, we are going to discuss about the S block elements, how they behave in liquid ammonia. Here, liquid ammonia is taken as the solvent. What is liquid ammonia? Or liquid ammonia is nothing but ammonium hydroxide. So instead of the solvent water, we are using ammonium hydroxide as the solvent. It is a non-aqueous solution that we are going to produce. So when alkali metals and alkaline earth metals are put in liquid ammonia, what we observe is that it forms a deep blue solution. So what happens when it is dissolved in liquid ammonia? So we take the general formula M for the metal. When M is put in excess of liquid ammonia, here we take the example as X plus Y molecules of ammonia. When it undergoes reaction, it forms a complex ion MNH3 X times positive plus electron which is ammoniated with Y. So in simple manner, I will explain here. We know that alkali metals are the ones which are larger in size, so it will easily lose electrons and become M plus ion and electron. When this metal ion is surrounded by ammonia, what happens here is the metal ion will be surrounded by ammonia ions. With the result, it will form the complex ion. Electron will be surrounded by ammonia. That will carry negative charge. This type of ion that is formed, or the electron that is formed, is known as ammoniated electron. This ammoniated electron will absorb energy from the visible region of light and it appears blue in color. This solution is conducting and it is found to be paramagnetic in nature. So what do you understand by paramagnetic solutions? These are solutions in which will be attracted towards a magnet. You find that the solution, when it is kept near a magnet, it gets attracted towards it. But when this solution is kept for long, you find that it will liberate hydrogen. So what happens there? When it is kept for long, you find that the metal ion accepts the electron back and it forms the metal. Subsequently, the ammonia solvent will surround here and you find that it will produce MNH2, liberating one hydrogen atom. You find that it is liberating hydrogen atom. So this compound that is formed is known as metal amide. This metal amide is found to be diamagnetic in nature. That is, it will be repelled away from the magnet and you find that it will be producing a deep bronze color. So initially, when alkali metal is put in ammonia, it forms deep blue solution. When it is in the concentrated condition, on standing, it liberates hydrogen gas with the formation of the metal amide and it forms a diamagnetic solution. The same is true with alkaline earth metals. So instead of forming the unipositive ion, there it forms dipositive ion. That is the only difference there. Both alkali metals and alkaline earth metals dissolve in liquid ammonia, forming deep blue solutions, which on concentrating it, we get bronze colored solution due to the formation of metalamide liberating hydrogen. The next topic that is discussed here is reducing nature of alkali metals and alkaline earth metals. What do you understand by reducing nature? We want to check whether the S block elements can act as good reducing agents. We know that metals are always electropositive. That is, metal will liberate one or more electrons forming the ions. So, the release of electrons or the loss of electrons, that is known as oxidation. So, you find that it can be remembered using the mnemonics oil rig. Oxidation is loss of electrons, whereas reduction is gain of electrons. How can you represent reduction? Reduction can be represented when an element adds up one or more electrons, it forms negatively charged ion. So addition of electron is reduction. So reduction is gain of electrons. Another important point that you have to remember is reducing agent is a substance which helps in reduction. Which itself gets oxidized. Whereas oxidizing agent helps in oxidation itself getting reduced. So, reducing agent helps in reduction itself getting oxidized, whereas oxidizing agent helps in oxidation itself getting reduced. Hope this much is clear. To understand electrode potential, we take the general formula Mn plus n electrons becoming M. The forward reaction occurs only if Mn plus is unstable, and by adding up electrons it becomes a stable configuration. But we know all metals are electropositive. That is, they easily give away electrons, forming metal ions and electrons. So with the result, you find that the configuration will be stable for the ions compared to that of the metal. So when we take the reaction Mn plus n electrons becoming M, the forward reaction is reduction. That means E naught value of Mn plus bar M For most of the metals, it is found to be negative. The meaning is metal ions will never accept electrons to form the metals. Instead, it will lose electrons, forming the metal ions readily. From this, we can understand that the metals are actually donors of electrons, or it helps others in reduction, itself getting oxidized. So, alkali metals as well as alkaline earth metals are good reducing agents. If this reaction occurs, you find that E value of Mn plus bar M, that is the reduction potential of Mn plus bar M, will be positive. And for metals, you find that the above reaction never takes place, with the result E0 of Mn plus bar M for metals will be highly negative. That means we understand that the metals are always electropositive. It doesn't undergo reduction, instead it undergoes oxidation. We have learned that a substance which undergoes oxidation can act as a reducing agent. So higher the negative reduction potential, more will be the reducing nature of the metal. What is meant by reduction potential? Reduction potential is denoted by the letter capital E naught. So reduction potential is the sum total of all the changes involved in converting the metal from the solid state to the metal ion in the aqueous state. So what all changes are involved? What all energy changes are involved in converting the metal from the solid state into the metal ion in the aqueous state? The sum together is considered as the reduction potential. So you find that metal from the solid state, first it has to be converted to metal in the gas form. So this is a change which involves solid to gas. That means the process involved is known as sublimation. So the energy involved here is known as delta H of sublimation. That is, we are supplying the energy in order to convert it into the gas form. Now, is it enough that we convert it into the gas form? No, it has to be converted to the ionic form. So when it is converted to the ionic form, it has to remove the electrons. So this is still in the gas form. So the energy involved here is known as delta Hi, that is ionization enthalpy. Now finally, this has to be surrounded by water molecules, and you find that the energy change involved here is known as hydration enthalpy. So the hydration enthalpy is always released, and so it becomes negative delta H of hydration. So what is meant by electrode potential or the reduction potential? E naught, the reduction potential, is the sum total of sublimation enthalpy, ionization enthalpy, and hydration enthalpy. So in most of the metals, you find that the E naught value for metals will be always negative. The reason is the sum of the sublimation and ionization enthalpy is less than the hydration enthalpy involved. In the case of copper, it is found to be E naught value Cu2 plus bar Cu is found to be plus 0.34 volt. This means that the sublimation and ionization enthalpy is not compensated by the hydration enthalpy. That means the hydration enthalpy value is less for copper, and with the reason you find that it has a positive value. That means copper cannot displace hydrogen from the acid. All other metals which are reactive, they have high negative value. Higher the negative value, you find that it has a tendency to get oxidized. That means it is acting as a better reducing agent. Thank you.